This is section 12.1, the beginning of chapter 12, our last chapter, yay! And it has to do with limits. This is actually the beginning of really of calculus, right here, this section. Move this down. What is a limit? Okay, a limit is a number, a value, where this graph is approaching. Sometimes it may exist at that point and sometimes it may not. But a limit is just the value as it gets closer from either side of the graph at that one spot. Okay, so this is how limits are written in general. There's this little piece down here. So as x is getting closer, oops, let's try. It's getting worse. As x is getting closer to some value, a, we have the function, so some graph. As it's getting closer to x on that spot on that graph, closer to this value of x that we want, it should equal some value. Some value. Okay. So this would be as x is getting closer to a at this spot. We go up to the graph and we see that this is where it would probably hit, and that would be the limit. Sometimes there's a hole there. The limit is still that spot. It doesn't exist at this spot right here. It exists here, but the limit is up here because it comes from the left, comes from the right, and that's where the limit is. So even if there's no value of what it equals and there's still a hole, the limit is still at this spot. All right. Okay, it says estimate the limit numerically and graphically. We're going to do it in the graph. So we want to put this function into your graphing calculator, which is not up. Hold on a second. Okay, so here is the graph of this equation. I put it into my y equals. If I go to my table, you can see now it says the limit where x is going towards 2. At 2, it says error right there because x minus 2 in the denominator. If you're at 2, you get 0, right? 2 minus 2 is 0. It doesn't exist there. So there's actually, here, there's actually a, oh, let me go back to the graph. So actually at 2, if I go follow 2 up, here there's actually a hole there. But as we're coming from the left, we're coming from the right, the graph approaches a value. And it seems to be approaching 5. Which should be, because if you look even at your chart, this is 3, 4, 6, 7, 8, 9. So it's approaching 5. So finding limits from tables. So we're going to put in tan 3x over x. I'm going to put that into y1, and then I'm going to put the second one into y2. So I put both of them into y1 and y2. I turned y2 off so I can only see y1. Oh, let me get rid of this stuff. There we go. So you only see y1. And it says we're going to do it from a table. We want to go to our table to see what it looks like first. Okay, we want to know as the limit is approaching 0. It says x is going to 0. Okay, so you have these values here. 0.05241, and at 1 it's 0.0521241. So somewhere between there, it hits something. You want to get super close. So I'm going to change my table set. We want to start at 0, because that's where we want to know where the limit is. And I'm going to change my tables to like 0.1, 2, we'll put 3 zeros and then a 1. This might be good enough. Go back to your table. Point 0.05236, 0.05236, okay. Well, they're all 0.05236. So let's see if it changes if we get a little closer. Go to table set, now change the delta table by 0.1, 2, 3, 4, 5, 6, 1. Now go back to the graph table. Oh, I I think it started at 0. 0. Yeah, it didn't change. 0.05236. Oh, you know what? Hold on. Go back to your... I'm not in radians. That's going to change this big time. Now go to my table. Look at this. It's 3. Make sure you're in radians. Common mistake. Need to be in radians. Okay, so I'm going to go back to my graphing calculator. I'm going to turn this one off and turn Y2 on. And we go to our graph. You can look at it. I don't know if you can see it. Not really. Okay. Let's go to our table. Well, above the 0, below the 0, both 0. Well, it doesn't help. Minus 3x squared. Huh. That looks funny. Square root x squared plus 9 minus 3 over x squared. It's supposed to be 1/6. Yeah, I don't know. The answer's supposed to be 1/6. I think I put something in the calculator wrong. This is 1/6, the answer, by the way. So you want to change your table. So when you're doing it through the table, make small values. Ask about B. It's supposed to be 1/6. All right, a Heaviside function h is defined by this. Okay, so if I graph this function, here's my little mini graph. Okay. It's 0 if t is less than 0. So it is this graph with a hole here. And then 1 if t is greater than or equal to 1. Find its limit as t is approaching 0. Well, coming in from the right, it looks like we're approaching 1, right? Coming in from the left, it looks like we're approaching 0. If you approach two different values, coming from the left and right, then the limit does not exist. Next one, we have cosine pi over x. I want to show you what this looks like in the graphing calculator. Clear that out, clear that out. We are in radians, so cosine pi divided by x, graph. Okay, if we zoom in, right there. Oh, crazy, crazy, craziness. See how it oscillates back and forth? And if you keep zooming in, it keeps oscillating back and forth. It goes back and forth, back and forth, back and forth, back and forth, back and forth. When it does that kind of a thing, limits don't exist there either. This one, there's an asymptote. So we want to find the limit as x is going towards 2 for this function. So if I look at my graph, we have 1 minus x on top. 1 minus x on top. Bottom is x minus 2 squared on the bottom. I'm going to look at the graph. Going down a 2. Oh, you can't really see it. So let's maybe make our window. Make this 5. So notice how it like jumped up a little and came down. It's going down again. So there's an asymptote, so I'll draw that picture. So this graph actually came up and went down. This is at 2. And then it went around, yeah. And it went this way. So there's actually an asymptote there, which means the limit doesn't exist there either. All right. You can read all this stuff on your own, coming from left and right. It just will denote by a little value up there. Left it would be negatives, right is positives. We're going to jump all the way down. You can read all that stuff. Okay, so for A, we're talking about the limit as x is approaching 2 from the left-hand side for G. So here's the graph of G over here on the left, right. As I'm approaching 2, going towards 2 from the left side, I'm going to follow this graph, and it looks like it hits it at 3. Doesn't exist at 3, but the limit is 3 though. So if I'm approaching 2 from the right side at 2, it's here at 1. But the limit of g of 2, because it approaches 2 different values, they didn't indicate which side to come from, then it doesn't exist because it's 2 different ones. All right, so now if we're doing 5, so I'm approaching 5. From the left-hand side, here's where 5 is. It looks like it's 2. The actual value of g of 5 is really 1. From the right-hand side, it's 2 again. Since they're the same anyways, you get 2. And here we're going to graph a function, graph x equals 8 and 2x squared. I'm going to change my scale and go up by 2s. So this before 8, 12, 16, 20. So x plus 8 for x is less than 3, so which means it hits at 8, and our slope is 1, right? So up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. Oh, but only to 3, so that's this point right here. And it doesn't have an equal sign, so we actually have a hole here at 3. There's that side. Then 2x squared, so at 3 is 18. At 4, it's like way up there. So this is like, actually it goes this way. It's like, whatever, it's up here. Okay, so that's our graph. All right, we'll do red now. So we're approaching the limit as x is going towards 3 from the left. So going from this, it looks like it is approaching 11. Going 3 from the right, looks like we're approaching 18. Because they are different, they don't exist. That is the beginning intro of limit.